what are common logarithms? So common logarithms are nothing but the log value of a number with base 10. The application of log table is you can evaluate this without the help of calculator. So applying the properties of logarithms and with the help of log tables we can find this. Every logarithms or every common logarithms that is a log value of any number base 10 contains two parts. One is called as the characteristic, another is called as mantissa. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to study about the evaluation of logarithm of some numbers. So here we require logarithmic table as well as anti-logarithmic table to find the values. Now before that, let us see what are common logarithms. So common logarithms are nothing but the log value of a number with base 10. For instance, we represent that in the form of log a to base 10. For example, log 1 to base 10 value will be equal to 0. We know that log 1 to base 10 value is 0 because 10 power 0. If we write this in the exponential form, this is nothing but 10 power 0. So anything to power 0 will be 1. So obviously the log of 1 value to any base has to be 0. Now if I suppose take log 10 to base 10, we know that log of any number with the same base is equal to 1. So this will be equal to 1. Now similarly here log of 100 to base 10 is equal to 2. So like this, so log of any number to the base 10 is considered as common logarithms. So we can find these logarithms value with the help of logarithmic table. But before that, every logarithms or every common logarithms that is a log value of any number base 10 contains two parts. One is called as the characteristic, another is called as mantissa. For example, let me take an example of log 25.63 whose value is 1.4085. So we can find this log with the help of log table. Now log of a number 25.63 is 1.4085. So here one is called the characteristic. So that means you will get a number in the form of a decimal form. So the integral part is nothing but the characteristic and the fractional part is called as mantissa. Remember, your mantissa value is always positive. So that means the fractional part of the log value will be always positive. So characteristic may be positive or negative or 0. Now here this is called as the characteristics. Now the characteristic of a number can be found by inspection. For example, now here I have taken an example log of 25.63. So what I will do here, I will count the number before the decimal point. So how many numbers or how many digits we have before the decimal part? We have 2 here. So 2 digits. So the characteristic here will become 1 in the form 2 minus 1. If suppose I will consider this as log of 256.3, then this 256 is a 3 digit. So therefore the characteristics will become 3 minus 1 which is 2, whereas the mantissa value for this will be 4085. So as the decimal point changes for a given set of number, the characteristic will change but the mantissa will remain same for the same 4 digits. So always we need to find the log in such a way that by looking at the decimal point, by deciding the number of digits before the decimal point, we can find the characteristic. Then how to find the mantissa value? Mantissa value can be found out using the log table. Let us see now using the value of mantissa with the help of logarithmic tables. Now this is a logarithmic table. So we have a number starting from 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now let me take an example here. I need to find the value of 10.63. Let me consider it as 10.63. What I'm supposed to do here, move towards the column containing 10 here. So this is the column which contains 10. So move horizontally with the row. So after 10, the next number is 6. So move along the horizontal row and note the number headed by the column 6. So what is this number? 0, 2, 5, 3. After this, further move towards the column here which contains this headed by the number 3. It is called the mean difference. So here the difference is 12. So you need to add these number. So now 0, 2, 5, 3 plus 12 will become 3 plus 2, 5, 5 plus 1, 6, 2, 0. Now to decide the characteristic of this, so log value of 10.63 will be in the form of 10 means there are 2 digits. So 2 minus 1, 1 is the value and mantissa will be 0 to 6y. Let me take one more example. Let me find the value of log value of 33.76. So what you are supposed to do, you need to move towards the column which contains 33. So here is the column 33. So move along the horizontal row which contains 33 and the next digit is 7. So that means you need to move horizontally and note the number in the column headed by 7. So this is the number 5276 is the number. So along the row 33, you need to note down the number headed by the column 7. So which is 5276. Next you need to further move along the mean differences. So which is headed by 6. So move along this row and headed by 6. So this is the column headed by 6. You have a 8 here. So 8. Now 6 plus 8, 14, 1 carry, 8, 2, 5. So the mantissa part will be, that is the fractional part will be 5, 2, 8, 4. So 5, 2, 8, 4. How to decide the characteristic? So before decimal point, you should see how many digits are there. Then you need to subtract the number of digits by 1. So how many digits we have? 2 digits. So 2 minus 1, 1. So the value of log value of 33.76 will be 1.5284. So log value of 33.76 is 1.5284. Now if I take the same log value as 3.376. See, the first 4 digits are same. So when you're taking the log value, you need to neglect the decimal point and you should consider the first 2 digits towards the row and the next digit in the column and the 6 in the column mean differences. So you should always take this as 3376. Now you will get this here 1.52484. Now here I have taken the same 4 digits but with the change in decimal point. So what happens here? The mantissa part will be the same because we'll consider this as 3376 separately. So however the numbers are distributed, you should always neglect the decimal point. So whether the number is after the decimal point or before the decimal point, but you should always consider the first 4 numbers in the given number. Now here, what about the characteristics value? So you need to check how many digits are there before decimal point. So we have 1 digit. So 1 minus 1, 0. So the value of log of 3.376 is 0.5284. Similarly, let me take the log of 337.6. So how to check for this? 33 headed by the column 33. Then move along the row containing 33. Note number headed by 7 and along mean differences, note the number headed by 6. Add those number. You will get the mantissa part same, that is 5284. But what about the characteristics? So we have 3 digits, 3 minus 2, 3 minus 1 is 2. So therefore it is 2.5284. So you can clearly observe this. Your mantissa will remain same for the same 4 digits. Only thing is the characteristic changes. Now let me take this as 0.3376. So obviously there are no numbers before decimal point. So 0 minus 1 will be minus 1, but in log we'll represent minus 1 as 1 bar. So what about the mantissa part? It will be the same. Similarly, we can calculate 0.03376. So here we'll get 2 bar. So always remember, so before and after decimal, if you have how many numbers of zeros are there, it is easy to write the characteristic. So we have 2 zeros, so obviously it will be minus 2. So 284. So look at these values. Everywhere the mantissa remains the same. Only thing, the characteristic changes according to the number of digits before the decimal points. Now this is how we will study the log of the given value. Now for example, consider log x to base 10 is equal to 1. So using the exponential form, we will write 10 power 1 is equal to x. So x can also be written as x power 1. So clearly we can find the value of x is equal to 10. Now the value of x is 10. Now suppose, consider a number log x is equal to 1.2456. So obviously without any base means it is already considered under base 10. Now log x is equal to 1.2456 here. So we need to find out the value of x. So that means, so 10 to the power 1.2456 is equal to x. But how to find the value of x here? So here we will use the concept of anti-log. Now here if we need x, then x can be written as anti-log of 1.2456. Now let us study how to find the anti-log of the given number. Now we have taken x is equal to anti-log of 1.2456. Now here, while calculating the anti-log, we will neglect this. We'll neglect the characteristic part. So we know this is the value of some log x. So obviously this is the characteristic and this is the mantissa part. So we always evaluate anti-logarithms only with the mantissa. So here we'll neglect the characteristic 1. Now we need to find out 0.2456. Let's check the anti-log table. So this is the table which contains the anti-log of the given values. So you can clearly see, so these are the mantissa part which starts from the first 2 digits here. Then we need to move along a column headed by the certain number. Then we will move towards the mean difference. So these are called as the mean differences. As we have done in the log, we will note a number headed by certain number in this first column, and again in the mean difference column we will note the number, we'll add them and we will write the number. So this is an anti-log which contains the values from 0.01 to 0.14. Next we have from 0.15 to 0.29 headed by the column from 0 to 9 and the mean differences from 1 to 9. So you will have the logs and anti-logs until 99 and 0.99 respectively. Now since I need to find out anti-logarithm of 0.2456, I'll consider this as 0.24, then headed by the column 5, then headed by the mean difference 6. Let us check the value. So this is the anti-log. We have here 0.24. So this is 0.24. So move along the horizontal row. We know that we need to find out the value for 2456. So we have 0.24. Then move along the horizontal row headed by the column 5. Note the number. So what is the number we have here? 1758. Note the number. 1758. Next again, after this we have a 6. So that means we should look in the column headed by 6. So which is 2. So add 2 here. So then this will be 1760. So this is the number. So the value is 1760. Now write the number here. So anti-log of 1.2456 is equal to 1760. Now we will take the characteristic value. So while finding the value, we will neglect the characteristic. But now we are taking the characteristics. So what is the characteristic here? How many digits in the 1? So add 1 to this number. So the value will be 2. So what does it mean? It means we need to place a decimal after 2 digits. So 1, 2. So the value of this is 17.60. So this is how we will calculate the anti-log of the given number. Now let me take one more example. Let me find anti-log of 0.3125. So here it is 0. So characteristic will neglect. We'll consider the number 0.3125. Now let us see the value of 0.3125. Now this is the anti-log table. We are considering 0.31. Move along the row 2, so which contains 2051. So 2, then again further move towards the column mean differences. It is 0.3125. So note the number headed by column 5 and here headed by column 2. Add these two numbers. So we have 2 here. So obviously it is 2053. So let's write the value. We have 2053. So what is the characteristic here? So there are no digits in the characteristic. So obviously it is 0. So 0 plus 1 is equal to 1, which means you need to place a decimal point after 1 digit. So here 2.053. So therefore the anti-log of 0.3125 is 2.053. Now with the help of the logarithmic as well as anti-log tables, we will evaluate certain problems. Using tables, evaluate or find the values of 2.345 into 12.72. We need to find out the log value of the given number. Now let x is equal to 2.345 into 12.72. Let me apply log on both sides. Then this is log x is equal to log of 2.345 into 12.72. From the properties of log, we know that log m into n can be written as log m plus log n. So therefore here I will write it as log 2.345 plus log 12.72. Now we will evaluate this. So in the left hand side we have log x. Now let's find the value of log 2.345. So we have 2.345. So neglect the decimal point here when you are finding the log. So how we will separate this? We will separate this as 2345. Now let's find the value. So in log table, so move towards the column here in the first column and note 23. Then move horizontally in the row containing 23. So we need to find 2345. Now let's move along this. Here it is 23 and headed by the column 4 is 3692. Then move towards the mean difference headed by the column 5 which contains 9. So add these two numbers 3692 plus 9. So 11, 1 carry, 0, 1 carry, 7, 3. So it is 3701. So the mantissa part here is 3701. How to decide the characteristic? By looking at the number of digits before the decimal. So before decimal we have 1 digit. So we will subtract 1. So 1 minus 1, 0. So the value is 0.3701. Similarly, if you find the log of 12.72, that means you need to move towards a row which containing 12. Then further move towards the column headed by 7. Note the number. Move towards the column headed by 2 in the main difference. Note the number. Add those two numbers. You will get the mantissa part. To decide the characteristic here, we know there are 2 digits before decimal. So 2 minus 1 is 1. Now what about the mantissa part here in 12.72? Now consider the column here 12. Move along the row which is headed by 7. So it is 1340. Note the number. We need 1. So we need 12, 7, 2. So next in the mean difference column, you need to see the column headed by 2. So you have 1. So the value is 1341. So 1340 plus 1 is 1341. So the mantissa part is 1341. So here we'll write 1341. Now we will add these two numbers. So the value will be 1.5042. Now this is log x. Since we need to find out the x value here, x can be written in the form of anti-log of 1.5042. So now while checking anti-log, we'll neglect the characteristic. We'll decide the value only for the mantissa. So we need to check the value under 0.5042. So now this is the anti-log table. So we have 0.50. So move towards the row and note the number headed by column 4. So it is 3192. So 0.04. Next we need 2. So further move along the row headed by the column 2. Note the number. So we have 3192 plus 1, which will be 3193. So x will be equal to 3193. So now since the characteristic value is 1, so add 1 to the characteristic. So then it will be 1 plus 1, 2. So place a decimal after 2 digit. Hence the value of x is 31.93. Next we have, using the tables, find the value of 12.567 into 15.674 divided by 0.5968 into 19.78. So the application of log table is you can evaluate this without the help of calculator. So applying the properties of logarithms and with the help of log tables, we can find this. Now here, let me consider this as log x. So we have log x is equal to log of 12.567 into 15.674 whole divided by 0.5968 into 19.78. Now you can clearly see here, it is in the form of numerator fraction. So numerator you have two numbers in the product form and denominator also you have two numbers in the product form. Using the properties of log, we know that log mn can be written as log m plus log n. And similarly, anything in the form of m by n, that can be written as log m minus log n. So using this property, I can write this in the form of log of 12.567 plus log of 15.674. Since these two are in denominator, it will become minus log. So minus log of 0.5968 minus log of 19.78. Now as we did the previous problem, with the help of logarithmic table, find the values. Now first let me decide the characteristics of these number. So we have two number before the decimal point. So therefore the characteristic is 1 here. Next we have two numbers before the point here. So again the characteristic is 1 here. Let's decide the mantissa part later. Let me put minus here. There are no digits before the decimal number. So 0 minus 1 is minus 1. So which is represented as 1 bar. Let's decide the mantissa part later. Now again here minus log 19.78. So 19 is a 2-digit number. So 2 minus 1. Therefore the characteristic will become 1. Now with the help of log table, so we need the value of 1256. So you have 5 digits here, but you always consider the first 4 number. So we need to find the value headed by the row 12, then move towards the column headed by 5, note the number, again move towards the column headed by 6 in the mean difference, add these two number, you will get the mantissa part. So 0990 is the mantissa part using the log table here. So next for 1567, we'll get the value in the mantissa as 1951 using log table. Next here for 5968. So here there are no digits before the decimal point, but when you are taking the log value, you always neglect the decimal point and consider the first 4 number. So you always decide under the row 59 headed by column 6 and then headed by column 8 in the mean difference. So therefore the mantissa part for 0.5968 will be 7758. Next, for the last one, we need to find out the value in the row 19 headed by column 7 and then headed by column 8 in mean difference. So the value will be 2963. Now, after evaluating this with the help of log table, we'll simplify the solution. Now, here clearly we know that 1.090 is a plus 1.1951 and here we have minus. So, we'll add these two numbers. Then we will finally get 0.9978. So, adding this and subtracting this value, we will get 0.9978. Next, we have here minus of this. So, how to write this? We always write this as minus 1 plus. I told you your mantissa part is always positive. So, you have to write this as plus 0.7758. Then evaluate this. You will get the value as 0.9978. Since you get negative value inside, multiplied by minus, you will get it as positive. So, the value is 0.2242. Now, once you add these two numbers, you will get the value as 1.222. Now, we have log x is equal to 1.222. So, x will be equal to anti-log of 1.222. Now, check the value in the anti-log. So, here you need to neglect the characteristic, you need to take only the mantissa part. So, you can clearly see there are only 3 digits. Then how to check? You need to check 0.22 under the column headed by 2, note the number. Now, here this is the anti-log table 0.22, move towards the row headed by the column 2. So, it is 1667. So, there are no next digit. So, we'll end up here. So, the digit is 1667. So, we'll write the value x is equal to 1667. Now, we'll take the characteristic. So, characteristic is 1. So, add 1, then it gives 2. So, which means you need to place a decimal point after 2 digits. So, therefore, the value of x is 16.67. Next, again using log, we have here square root of 14.5 into cube root of 8.571 divided by 16.751 whole to the power 2 by 3. So, now we know that the third property of logarithm, when you have a power, then you can write it in the form of whole number as n log m. So, here let me consider this as log x, which is equal to log of square root of 14.5 into cube root of 8.571 whole divided by 16.751 to the power 2 by 3. Now, applying log here, we can write this as log m plus log n. So, I can write this as 14.5. I'll write square root as 1 by 2 because the index form of square root is 1 by 2 plus log of cube root index form is 1 by 3. So, I'll write it as 1 by 3. So, next is, this is in the denominator. So, I'll use minus log n form. So, 16.751 whole to the power 2 by 3. So, log 16.751 whole to the power 2 by 3. Using this property, I can write this as half log 14.5 plus 1 by 3 log 8.571 minus 2 by 3 log 16.751. Now, using the log table, we will find the values of this. We can decide the characteristic by inspection. So, clearly 14 is a 2-digit number. So, therefore, my characteristic will become 1. Now, we need to check for 14.5. So, when you check for 14.5, the mantissa part will be 1614. Next, we have 1 by 3. We'll find the value of log 8.571. 8 is a single digit. So, the characteristic is 1 minus 1, 0. Now, we'll decide the log value in 8571. So, by splitting this in the form of 8571. So, therefore, the value of this will be 9331. Next, we have minus 2 by 3. It's a 2-digit number. So, 16. So, the characteristic is 1. Now we will take the value in a row containing 16, column headed by 7 and then column headed by 5. We can neglect 1. So the mantissa value is 2240 using log table. Now evaluating this, we'll get the value 0.5807 plus 1 by 3 into this is 0.3110 minus 2 by 3 into this is 0.816. So simplifying this, we'll get log x is equal to 0.0757, which means we need to find x by taking anti-log of 0.0757. So let's check the value of 0.757. So that means in the anti-log table, you need to check the row containing 0.07, then move towards a column headed by 5, note the number. In the main difference, move towards the column headed by 7, add these two number. So by verifying this, we'll get the x value as 1191. Now this is the digits we'll get. Now see the characteristic, so it is 0. So 0 plus 1 is 1. So therefore we need to place a decimal point after one digit. So therefore the value of x is 1.191. So this is how we will calculate the product of decimals or any fraction kind of a thing without using calculators. So other than this, we also have an application of log and anti-log in certain condition. Let's take an example here. Find the number of digits in the integral part of 3 power 20. So we know that in any number, for example, like 1.2345. So this is always considered as an integral part and this is an fractional part. So we can count the number of digits in the integral part with the help of log. How? Let me take this as x. So x is equal to 3 power 20. Then I'll take this as log x is equal to 20 into log 3. Now 20 into, let's find the log 3. So there is nothing means we'll just move towards the row. So how to find log 3? Because log table always start from 10. So if there is nothing made, we'll move towards 30. We'll take the value of 30, then we'll change it. Since there is only one digit, your characteristic is 0. And when you check log 30 value, it will be like 4771. Now when you multiply 20 to this, so you will get the value of 9.542. Now to find the number of digits in the integral part, so number of digits is equal to, we'll decide the characteristic. Here the characteristic is 9. So we always write 9 plus 1 is equal to 10. So therefore, there are 10 digits when you take the integral part of 3 to the power 20. If the characteristic is 8, add plus 1, so there will be 9 digits. If the characteristic is 2, then add 1, then there will be 3 digits in the integral part. This is also one of the application of log. Next, the one more application of log is to find number of zeros after decimal and before significant figure. For example, if you consider here 0.00375. So after decimal and before a significant figure, we have 2 zeros here. So with the help of log, we can find the number of zeros between a decimal point and significant figure. So let's check by taking an example here. So I have taken 0.7 to the power 55. We'll take x is equal to 0.7 whole to the power 55. Then log x is equal to 55 log of 0.7. Because this is in the form of m power n. If we apply log, then it will be n log m. So 55 log 0.7. Now we will find the log value at 70. We don't have any log value at 7. We'll find at 70. If we don't have any number, we can consider it as 0 after decimal point. So we'll check it at 70. Then we'll write the value. So log of 0.70 or log 70. So that will be 8451. Now, to decide the characteristic, there are no numbers here. So, it will be always 0 minus 1. So, we will write it as 1 bar. So, now, before evaluating this, we will take minus 1 plus 0.8451. So, multiplying and simplifying this, we will get the value as minus 8.5195. Now, here what we will do, we will separate this, minus 8 plus 0.5195. So we'll add minus 1 and we'll add plus 1 here. So this is 0.5195. So then this will be like minus 9 plus 0.4805. So when you have a negative here, now here we get log x is equal to 9. Here we can write 4805. Now decide the characteristic here. We'll not take it as minus 9. We'll take it as 9. So the characteristic is 9. When you're finding the number of zeros between the decimal point and significant figure, we always subtract by 1. So 9 minus 1 is equal to 8. So here, therefore, there are 8 zeros between the decimal point and the first significant figure of the number 0.7 to the power 55. For instance, if you have 8 as a characteristic, then we'll take 8 minus 1. If we have 6 as a characteristic, then we'll take 6 minus 1 as 5. So there will be 5 zeros or 7 zeros between the decimal point and the significant figure. So this is also one of the application of logarithm. So studying common logarithms helps us to evaluate certain problems which is in the product or a quotient form where the numbers are in the place of decimals. Now here it also has an advantage of finding the integral number of digits in the integral part as well as finding the number of zeros between the decimal as well as the significant figure in the exponential form of a number. So I'll meet you in the next session with the new chapter. Until then, keep watching, keep learning and keep exploring. Thank you.